In software engineering, we are taking chapter number 34, which is project scheduling. What is project scheduling? Project scheduling is the roadmap which will guide all the project activities. Most of the time, we just hear that project failed, this project failed. Now, why there is delay? Why the project failed? Before talking about project scheduling, let us know what are the reasons why the software or any kind of project is delivered late. The first reason is unrealistic, aggressive deadlines. That is, someone from the outside who is not from the software team, maybe in some managerial position. Now, he is going to say, okay, you have to do the project in 1.5 years or 2 years. Now, this time is forced on the managers and the practitioners, that is the programmers. The second reason may be the requirement of customers keep on changing. And since the project schedule has already been made, it is not reflected on the schedule, or schedule doesn't change with respect to the changing requirement. There may be a case where the honest underestimation of amount of effort or the number of resources to be employed to get the job done is not properly managed or understood or even underestimated. For example, 10 people, only 6 people are being given the job or hired. There are certain risk factors which are predictable or even unpredictable. They are not even considered, or even if they are considered, there is no contingency plan, there is no mitigation policy. There can be some purely technical difficulties because you cannot foresee them in advance. So there are certain technical difficulties which may come. People, humans, some may get ill, some may leave the job, there are so many things which can happen. Sometimes miscommunication. There is a hierarchy in the project team. So someone will say something, or miscommunication, the message is not being delivered, like this. Sometimes the project management or project manager, he does not recognize, he failed to recognize that the project schedule is not going up to the mark, or we are behind schedule. And then he doesn't do anything to correct this problem. No action has been taken. So these are the cause of failure. In the project scheduling, what are the basic concepts? The most important here is the aggressive or unrealistic deadlines. For example, 2 years it will take for work to be done, and you're just being told, okay, you have to do in 1 year, or say 1.5 years. So these are the fact of life in the software scenario, in the software field, in the software business. Unrealistic deadlines will be there because all is guided by market. Because if you don't give, the other may have the competitor may launch his product. So if the deadline is unrealistic, a competent project manager, as a competent project manager, what should you do? Protect your team from these schedule pressure, undue, unrealistic, and reflect the pressure back to the people who are the originators, who have created this pressure. So in case of unrealistic deadlines, what you're supposed to do? If you can't complete it, there are certain ways to mitigate. The first one is, all the historical data from the past projects, please use that to estimate the time, the effort, the duration, all these. Then determine the estimated effort and duration, as I just said, using the historical data or past projects. Then try giving an option of incremental process model, or use the incremental process model. That is, if you have, say, 50 functions to be given, choose the 20 basic functions and then give it. These are the critical functionality, and these are imposed in the deadline, but others can be delayed further. and just document all the plan you have made. Then meet with the customer. Try to meet along with all the detailed estimate you have created. Explain why, in a very kind words, this deadline which is being imposed on us is really unrealistic, because all the estimates what you have done has to be very prominent, has to be realistic, and also that what kind of percentage improvement every increment you are going to give in order to achieve the deadline. That is, indicate the percentage improvement. Also offer the incremental development strategy as an alternative. So this you can do. Project scheduling. What happens here is that we need to find out the time or schedule when what work will be done. So in a technical project, the whole activity or whole process, you have process like the waterfall model or the spiral you choose. These processes are divided into activities. These activities are divided into tasks. So finally, you have to have many small tasks. The technical project, there can be many small tasks. For example, waterfall model. These different stages of the model. And these tasks which you have decided, some of them may lie outside the mainstream. That is, when you have decided these are the tasks, they may be completed without any worry, because they are not going to impact any kind of impact on the project completion date. They are outside the critical path actually. So these can be done. These are tasks to be separated out, but these I am showing they are outside the mainstream. But there are certain tasks which are on the critical path. This red line you see, red arrows, this is a critical path. What does it mean? If these critical path, the tasks which are lying on it, if they fall behind schedule, the completion date of project is put into jeopardy, or it will suffer. So as a project manager, what is your objective? Your objective is to define all the project tasks, whichever tasks are possible. First thing is this first, deciding what tasks are to be done. Then all these tasks, there will be some interdependency. They will be dependent on one another. So build a network of that. Build a picture presentation like that. Identify the task that is critical. You need to know and show the critical path. For example, in 50 tasks, 10 are critical. This will be the central line of the path. Then track their progress, and to ensure that delay is recognized every day, one day at a time. Okay. So controlling and tracking is as important as making the project schedule. In project scheduling, you must have a schedule to monitor and control project. As I mentioned, making a project schedule is very important, but monitoring and controlling is even more important. So let us see what is software project scheduling. This is an activity that distributes estimated effort across the planned project duration by allocating the effort to specific software engineering task. Okay, basically scheduling is timing. What work will be done when? So which task is going to completed when? This will be the timing being given. Every task will have a deadline. I'll just give you a hint here. See, this is the task starting in January, ending in mid-March. So this is a kind of task. This is a scheduling you have to do. And this is to be done for every task which you have finalized. Okay, depending upon the project. So for example, this eighth task is going till end, but it is starting just in the beginning of March. During the early stages of the project planning, you don't need to make it very microscopic. So a macroscopic schedule may be developed, because this will identify all the major process framework activities of your software engineering activities and the product functions to which they are applied. That is, what are the major framework activities that is the macroscopic schedule will be made. But as the project proceeds, as the project gets underway, each entry on the macroscopic schedule, which we just did in the early stages, this needs to be refined into more detailed schedule. That is, the activity, the task under activity have to be properly told this is the time. So specific software actions and tasks are to be identified and they need to be scheduled. So scheduling for software engineering projects can be in two ways. That is, the schedule is already given to you. That is, end date for the release of the system or the software has already been imposed or told or given to you, already been established irrevocably. You cannot say anything, you cannot argue for anything. Okay, it is irrevocable. And the second thing is, maybe you are given a choice. End date will be set by you as a software engineering organization. These are the two ways scheduling can be done. For any project scheduling technique or management activity, this project scheduling, it has certain basic principle. Every project manager has to understand and know what are these basic principles. The first one is compartmentalization, division of the work, properly modularizing the task. That is, the project must be compartmentalized or divided in the way of divide and conquer into a number of manageable activities and tasks. For example, a framework activity or the process, under this you will have activities, under this you will have tasks, under this you will have functions. Interdependency. There will be different tasks, they will have some interdependency. That is, some tasks they may be in sequence, other may be in parallel, some may be concurrent, some may want the product to be delivered to the another work product. That is, let me show you here. Now these are all the work tasks. So this is the schedule. In week 1, what time it will start, what time it is end. And all that which are working together, these are the parallel activities. Some are serially working. Okay. For example, if you see week 2, last 2 they are serial. And then this diamond shape is a milestone. Some activities cannot start or commence until work product produced by another is available to this activity. There are certain tasks, they may work independently. Now the time allocation. Now each task which you have decided must be allocated some number of work units, person days of effort, what time, what people. Okay, that means it must be assigned a start and the end date, completion date, that are a function of the interdependency. You have to keep in your mind interdependency, and whether the work is done in full-time basis or part-time basis. Because part-time time will take longer, full-time the time will be less. Effort validation. Now what happens is, how many people you have allocated for what time. So ensure that no more than the allocated number of people have been scheduled at any given time. For example, 2 people working for say 7 days and 3 people working for say 3 days. More effort has to be allocated to number of people that work. Define responsibility. Every single guy has to be given a responsibility and a schedule. That is, you are a specific team member, you need to do this task and this has to be completed in this time. Then you have to have a defined outcomes. Every task should give some outcome, should have defined outcome. What is the deliverable? What are the work products? That also comes under defined milestone. Every task should be associated with a project milestone. What is a milestone? The project milestone is when one or more work product or the output have been reviewed for the quality and has been approved by the seniors and the review team and the quality people. Then we say, okay, we got the milestone. The relationship between people and effort. Now, how many people are to be introduced, hired, or put into work, and what effort? Effort is basically people. It's all about people. It comes in person month. One person in 1 month, how much work he will do. So there is a common myth, which is prevailing, that if you are digging a hole, there are 4 people working for 4 days, make it 8. They will work in 2 days. Will it happen? In mathematics also, the result will be different. So this is there in software engineering also. If we fall behind schedule, we can always add more programmers and catch up later in the project. This is not true. That is, if you put more people, the work will be done in no time. This will have a disruptive effect on the project, because your schedule will slip even further. For example, these are new people. A person is guiding them, teaching them. So the new people has to learn. That will take time. The person who is actually working on the project right now, he will be a tutor. So he will not be working on the project. He is actually tutoring. So taught and tutor, all these, the project will suffer. And more people means more communication. Number of paths will increase. The complexity of communication will increase. And that will even more slip your schedules. So these are some inherent factors which are to be considered. Over the years, the different data, it may be empirical data or theoretical analysis, it has demonstrated that the project schedules are quite elastic. They are elastic. But not at the end of the project. That is, if you are given a time that this is the time you have to complete, it may be elastic. It is possible to compress a desired project completion date by additional resources to some extent. That is, you can compress it, adding some certain additional resources. It is also possible. I'm not saying that, if you are putting the effort or the programmers in the last phases, you will fall in trouble. I'm just saying, if you have a project schedule, you can stretch it, you can compress it. That is, it is also possible to extend a completion date. You can stretch it and you can combine it, but not at the end that, oh, this time nothing is working, put more people. Okay. The relationship between people and effort. Now this figure is very important. This is a PNR curve. This stands for Putnam, Norden and Rayleigh curve. And this is giving an indication of the relationship between the effort, which is actually the cost also, effort applied on the y-axis, and on the x-axis you see the delivery time for the software project. So we need to see the graph, how it is shaping in terms of effort and the development time. The curve, what it is indicating? There is a minimum time t0 here, and this indicates a flat curve. This is the least cost of delivery. What I'm trying to suggest is the delivery time that will result in the least effort consumed. Least effort, this is the time t0. Now if you go to the left, that is to the y-axis or to the origin, that is, you want to accelerate the delivery, you want to compress the schedule, project schedule. The curve will rise non-linearly. You see the curve? It is going non-linear. This is the non-linear curve. If you want to decrease the time, you want to accelerate the delivery. This is quite straighter here. That is, I am talking about T0. See, let us take an example. If you want to take compress the time, you want to complete it at TD. The effort will be ED. Now you see, a level of effort ED will be required to achieve a nominal delivery time TD that is optimal in terms of schedule and available resources. It seems to be okay. Okay. But although it is possible to accelerate the time delivery, you see the curve. It rises sharply. The effort has increased so much. So PNR curve indicates project delivery time cannot be compressed much beyond this 0.75 TD, because beyond 0.75 TD I'm talking about the left hand side, going on the left hand side. This below this 0.7 or on the left of 0.75 TD, this is an impossible region. impossible zone, because at this time, if you want to compress and go on into the impossible region, the project moves into the impossible region, and this is full of failure. The risk of failure becomes very high. And there is one more relation. Where is TD? It is in between 0 and T0. So just add 0 plus T0 by 2, that is going to be TD. So TD will be equal to twice of TD. That is also a relation. The lowest cost delivery option, T0, is actually twice of this TD. What implication is here? The implication here is that delaying the project delivery, if the project delivery or project schedule can be stretched, the cost will be less. Now let me show another aspect of this graph. These are 4 parts I am showing. The left one is the impossible zone. That means it cannot be completed within a certain time. First one. This region is the overstaffed, completed fast but inefficient. This is the linear range. The efficient staffing, manpower trade-off with time is good. This is possible. The last one is understaffed, becomes also inefficient. If you have less staff, inefficient. Now the software equation which we already had discovered and learned, this is derived from the P&R curve and demonstrate highly non-linear relationship between the time to complete and the human effort applied to the project. So this is a non-linear curve. It has various independent variables involved. The B and B, let me show you here. I showed you this software equation. Now B was the special skill factor, P was the productivity factor, time was in duration, the project duration, E is the effort in person month or person years. So now the number of delivered line of code, the source statement, L is related to the effort and development time by this equation. We already seen that. L equals P into E raised 1 by 3, T raised 4 by 3. Now L is the lines of code, effort. How they are related? Let us see one more. E, as I said, E is the development effort in person month. E always in this is the unit of E. P is the productivity parameter, and then we have this P is a specific value that reflects a variety of factors that lead to high quality software engineering work. This P may range from 2,000 to 12,000 depending on the type of the project you are undertaking, and T of course is the project duration in calendar month. Now let us rearrange it. A certain rearrangement, this effort E will give a very good equation. L raised 3 divided by P raised 3, T raised 4. So let me write it because we are going to use it in an example. So E is the effort spent in person year. Please remember person year, over the entire life cycle for the software development and the maintenance part also. And T is the development time in years. Please remember that here in this equation the time will be in years. Now if you have the amount that is say $8,000 is paid per month to a person like this, you can also compute the cost. We have already done this in the previous discussions while we were doing the project estimation. But let me take an example of this particular equation. Just consider a complex real-time software project estimated at line of code as 33,000. The capital L is 33,000. The effort is 12% month of year. So let me just write it and put these values. I just want to show what is going on here. Effort is 12 and 33,000 is L, and we have to cube it, and P is 12,000 you are going to take here, and this time I am talking about. Okay, T to the power 4. So now, when you find out the time, there will be some time will come. Okay. Now, if I make this 12 as 8, what will be the time? The time will be 1.3 years. That is equivalent to 15.6 month. You can do this mathematics. Now, if we extend the end date to 1.75 years, that is T from 1.3, if I am changing it to 1.75 years, what will happen? This is a highly non-linear nature of the model. What it will give? Now I'm stretching, I have to use P as 10,000. You can calculate. I'm just writing the equation now. The effort will be L is 33,000. P I'm taking as 10,000 because we have stretched it. Change the time. 10,000. And time is 1.75 to the power 4. When you compute it, the effort in person years will come as 3.8. Now that means that if you extend it from 15.6 to 20.1 month, that is extended the end date by 6 months, we can reduce the number of people from 8 to 4. This is what the relationship between people and effort means. Effort distribution. Now in a software development life cycle, there are different phases. So what phase will take what number of project estimation, project effort distribution, this we need to see. Generally accepted guidelines is like this. A recommended distribution of effort across the software project is referred like this: 40, 20, 40 rules. Let me reiterate. A recommendation distribution for software process is 40, 20, 40 rule. What does it mean? It means the first part, that is the front end part, that is the analysis and design part. Once you got the requirement, you have to do the requirement analysis, and the design part, that is going to take the 40% of the effort. The similar part, 40% will be given to the back end part, that is the testing and debugging part. Okay, coding will take around 20% of the effort, coding part, and this is 20, 40, 20, 40. And project planning, because it takes a less time, 2 to 3% of effort is acceptable. Customer communication and requirement analysis around 10 to 25%. See, these are the numbers. You can change it depending upon your project. So you can see the difference in the number which I am telling. Software design, 20 to 25% of effort. And this, just let me add this testing and debugging, it's around 30 to 40%. So what you see in this table in the above part, that is the actual value you need to remember. But basic thing is 40, 20, 40 rules is adopted. Defining a task set for the software project. Now, for any work to schedule, those work have to be compartmentalized, being given time, and properly arranged so that they can be tracked and controlled. So an effective software process should define a collection of task sets. Task sets means a set containing various tasks, and each designed to meet the needs of different types of projects, because the projects can be of different type. A task set is what? If I make a collection of some certain task, that is called a task set. And this will consist of what? It will consist of the software engineering work task. That is, a task set will contain the task, different tasks, work to be done, and milestones, that is when it will start, when it will end, what time, duration, etc. And what will be the output, that is the work product after doing this task. And finally, the quality assurance strategy, like a filter. So in a project schedule, a task set must be distributed on the whole project timeline from start to finish. So the task set, as I said, it will vary. Task set for different projects will be different. So the task set will vary depending upon the kind of project, the type of project. So what can be the different type of project which we are talking about? First one is the concept development projects. Now, as we are going to take the example of this, so you need to know that this is initiated to explore new business concept or application of new technology. Say new technology has come, new concept has come, a business concept. Now this concept development projects work for that. The second type is new application development projects. Now customer is coming to you. He says, I want an e-commerce website. That is a new application development projects, because this is a specific customer request. The another type is application enhancement projects. Now there are certain softwares projects which are already there, and they may go certain major modification in terms of function, in terms of performance, in terms of different interfaces to be opened and connected. So for example, the UDP can be changed to TCP/IP like this. Application maintenance projects, it starts when then we need to correct, adapt or extend the already existing software. So correction, adaptation and extension, this comes under the maintenance projects. Okay. Now this is the fourth one. Finally, the re-engineering projects. Re-engineering projects, that is, there is already a software which is being used that is called a legacy software, 1960s, 1970s like that. Now if you want to rebuild this system as a part or as a whole, means completely or some part has to be rebuilt. So any project type you choose, many factors that affect, that guide or influence the task set to be chosen. This ultimately the project scheduling is all about choosing the right task and then doing the timeline activities, that is tracking, control and progress. So first thing is the size of the project. Small, complex, moderate. Number of potential users of this software or the project. What is the mission criticality? Is it a technology development or it has to be completed on time? What is the time duration for which it is going to be used? Application longevity. And whether the requirements are clear to us. Stability of the requirement. Whether you are very clear about what the user want. Then the ease of customer or stakeholder developer communication. That is, if you can communicate with the party, then you can easily make the software because you are quite sure about the requirements. Then the maturity of applicable technology. Whichever technology you are going to use or develop, is this mature or not? And then the performance constraint. For example, maturity I was talking about 6G. It has not come, so you cannot do anything for that until it is matured. For example, a file transfer is there, a performance constraints I'm talking about, 1 GB in 1 second. Is it possible? Can you do it? And whether this software will be as a desktop software or it will be inside your washing machine or your microwave, that is the embedded, non-embedded. Project staff, how many people? 2, 20, 200. This also influences the task set. The re-engineering factors. How much needs to be changed? How much needs to be adapted? How much needs to be extended? A task set example. So let us take the project. There are different 5 types of projects. So concept development projects. As we know, they are initiated to explore the new business concept or application of new technology. So this concept development projects, let us see how we can make the task set. So these concept development projects, they are approached by certain major tasks, defining them. That is how to find out the major task first. Major task means the work. That is, they have a prescribed visible output. First one is concept scoping. Concept scoping, because in concept development projects, the first thing comes is the development of scope. So this determines overall scope of the project, what you want to do, what is your underlying idea, and what are the constraints. Then we have to do the preliminary concept planning. And this planning establishes organization ability to undertake work implied by what? By the project scope. What concept scoping you have done, then what is your ability, what work you are going to do with respect to this scope. And technology risk assessment. As this is a new technology work, concept development projects, here we evaluate the risk, the problems associated with the technology to be implemented. Proof of concept. This demonstrates the viability of a new technology. It's all about new technology and new concept which we are trying to achieve. Then the concept implementation. This concept implementation implements the concept representation in a manner that can be reviewed by whom? Customer, and is used for marketing purposes when it is to be sold, when a concept must be sold to other customers or management. Then we'll do the customer reaction, that is to solicit the feedback on a new technology concept and also to our target specific customer applications. This is the major task we are talking about. Now, when we have devised and found out the major task, next part is to refine the major task to get the actual task which has to be put on the timeline as an activity or as a task. So the macroscopic schedule, that is the bigger schedule, must be refined for a major task to create a detailed project schedule. That is, from macroscopic you have to go to microscopic. So this refinement is decomposing these major tasks which we have already defined into a set of subtasks that can be put in a task set. Okay, this different tasks, how they are related, their concurrent, parallel, sequence, which way. But before that we have to decide what are the subtasks. Let us take the first major task of the concept development project which we just saw. It is concept scoping. So the major task is concept scoping. Now let us see how are we going to do the task decomposition in this case. First we'll start with the concept scoping. This is the first task, task 1.1. And you please remember 1.1, 1.111, all these are the subtasking. The first one will be to identify the needs and benefits and potential customers. The second part, we have to define the desired output and control and input events that drive the application. Now we have to begin the task 1.1.2. We are trying to now make the subtasking or this task set are created for 1.1.2. So we begin this task and now it becomes 1.1.2.1. We started with 1.1, then we came to 1.1.1, then we came when 1.1.2, then we went to 1.1.2.1. These numbers I'm just saying that this is how we are decomposing it into different tasks which will be actual activity of the task or the functions. So first we have to do the review, written description of the need. Then we have to derive the list of customer visible outputs, inputs. Then we have to do again the technical review, reviewing the output input with customers and talking to them and revising if it is required. Then this work is done. This task has been defined now. So these are the subtasks we have made. Then we define the functionality behavior of each major function. Okay, this is what have to be done. Then we begin this task 1.1.3. These are the subtasks for 1.1.3. So 1.1.3.1 will be the technical review. So what we have got in 1.1.2, we have to review the output and input data objects derived in that task. Then we have to derive a model of functions and the behaviors, because we are talking about functionality and behavior here. Then again we have to do the technical review, reviewing the functions and behavior with customers, talking to them and getting the feedback and revising them. Then the 1.1.3 is finished. Okay, now we have to isolate those elements of the technology that has to be implemented in the software. Then research availability. If there is existing software, there is already a software present, then this will be 1.1.5. Then we have to define the technical feasibility. Okay, whether it is feasible or not. For that we have to do all the technical stuff for that. And finally, making a quick estimate of the size. If we are all aware of all this, let us make the estimate. And then we have to make the scope definition. This was the major work of the concept scoping. And then we end the first 1.1. So this is how the task decomposition is done for a major task which was concept scoping. Defining a task network. Now, what major task we have decided with respect to the scope. Now we have to make the task set, and this task set will give you certain result, the work product. But these tasks, how they are related, they are sequenced, they are in parallel, they are concurrent. One product is required for another. So individual tasks and subtasks have interdependencies based on their sequence. So for example, if two people are given some tasks, so when more than one people is involved, development activities and tasks may be done in parallel. Therefore, the concurrent tasks which are going on together must be coordinated so that they complete when later tasks which are waiting for the work products produced by the previous tasks. A task network or the activity network. Please remember, the task network is also called as the activity network. This is a graphic representation of the task flow for a project. Task network, activity network. You should see here, it's like a computer network or a people network, different kind of network. So here the network is of task. This is a graphic representation of task flow. Now this 1.3a, 1.3b, 1.3c, they are working in parallel. They are in parallel, but some are sequenced. So task network depicts major software engineering tasks. And you see here, this is a schematic task network for a concept development project. I told you about 5 projects. This is for the new technology or new business idea. Tasks that lie on the critical path. The longest path possible in this network is called the critical path. So tasks that lie on this critical path must be completed on schedule, else the schedule is definitely going to suffer. You have to do all this task at the first go. Others, they may not lie on the mainstream, they can be deferred. Project scheduling. Here we have the PERT, CPM, Gantt, all these. So these are generalized project scheduling tools. These are normally used in the project management. So these generalized project scheduling tools and techniques, this can be employed and applied to the software development projects also. So we have 2 project scheduling methods. Gantt is also there, we'll talk about that, but the project scheduling methods, especially PERT, Program Evaluation and Review Technique, and the Critical Path Method, CPM. So here, first one, there are ways which we can differ. First one is the statistical method. The other one is the deterministic method. The first one is the estimation is not that much clear. The CPM, the estimation is quite clear. The durations are clear. Okay. And there are various differences here. We'll talk about the differences just now. But PERT, actually it came first. CPM is a refinement or a way to represent where we definitely want our critical path method or critical part to be seen. So PERT, Project Evaluation and Review Technique, is a statistical tool used in project management that was designed to analyze and represent the task involved in completing a given project. In this critical path, the CPM, a schedule network analysis technique used to determine the amount of scheduling flexibility on various logical network paths in the project schedule network and to determine the minimum total project duration. So both these techniques, they are driven by certain inputs. So they are driven by information already developed in the earlier project planning activities. For example, if you assume all this has been done, that is the estimates of the effort already been done, a decomposition of the product function already been done, then along with this, the PERT and CPMs and the Gantts, they need certain input and they're driven by this input, like the selection of the appropriate process model and the task set, because these task set will be put in the network or the timeline, and finally the decomposition of the task, if the major tasks are there, defining them in a task set. Program Evaluation and Review Technique, PERT. In this PERT, how do we do this? Let us take a very simple example. Here you see activity ABCD. What are the activities preceding to these are given here. The completion days are given in PERT as optimistic, most likely, and pessimistic. For example, 5 is the optimistic for A, activity to complete. Pessimistic says 7. Most likely is 6. So we don't have a single number. For every activity, there will be completion days, but there will be 3 options or three way to think of it. That is why it is statistical. And what do we get? The final number will get from first row I'm taking 5 plus 4 into the most likely, then plus the pessimistic. So optimistic plus pessimistic plus 4 into the most likely divided by the 6 number. So this is the value which you are going to use, and you will do it for all the rows. So this is PERT. Now the example is, see, we have activity A, B, C, D, E. The duration are given as 3 days, 4, 5, 3, 4 days. And it depends on, or you can say the preceding activities are A like this. So we'll start with start. There is nothing before A, so we'll start with A. And what is the duration? 3. So we'll make a round. That activity has to be written here. Outside you can write the day. Okay? A. Now go to the depends on and see all those activities which are dependent on A, or A is preceding these. So B and C. So from A, 2 arrows will come out. 1 for B, 1 for C. B and C we have written now. Same way. And 4 and 5 are the duration. So we just wrote those numbers near these round circles. Now B and C. Which activity are depending on B and C? D and E. From B there are 2 activities related. So from B, 2 arrows will come to B and E. But you also see that E is dependent on, or E is coming from C. So from C there will be 1 row to E. So here is the arrow to E. And what is the time of D? 3. What is the time of E? 4. So now that things are finished, so you just put a finish. This is a PERT chart, PERT network, PERT way. Critical path method, or CPM. This is almost like the PERT. There are certain differences. The difference is that here we talk about the critical path. This is deterministic. And in PERT, if you remember, that we used to give 3 values for this duration. For any activity to complete, there are 3 values. One will be optimistic, one will be pessimistic, one will be most likely. So what do we do? O plus 4m plus p divided by 6 we do, and then we find out the duration. That was done in PERT. Here, the notes, how we are going to write it. In the center, we'll write the activity name. Here, for example, A. A has duration 4, so we'll write 4 here. ES and EF, ES stands for early start. EF is standing for early finish. Let us take an example. Okay. Now we'll start with A. There is no predecessor, there is no activity before A and C. So we'll start with start, and there will be 2 arrows from start, 1 to A, 1 to C. This is 1 arrow. This is actually a flow. So A and C. So you're writing A and C in between. And what are the days? Duration 4 and 5. You're writing just above it. Like this. For A it is 4. For C it is 5. Now go to the predecessor and see all activities which are where A and C are predecessors. So A and C. A and C, B will come from A and C, and D will come from C. So from A and C, there will be 2 arrows to B, and from C there will be 1 arrow to D. Okay. Now duration also we have written. So B is dependent on A and also C. D is dependent on C. The number is duration I am writing just above it. Okay. Now E is dependent on, or E has predecessor B and D. So B arrow and D arrow will go to where? To E. Right? And the time will be 5. Finish, just put a finish. And it is coming from E and D. So from E, from D, the arrow will go to finish. End. Right? Now what about these early start and early finish? Let us take an example. These both are starting with 0. When will B come? Because B is having arrow from A and C, but A duration is 4, C duration is 5. What is the maximum? 5. So we have early finish, you have to put 5 as B. Others are also there. Okay. Next next is the critical path. See, we'll start with A, B, E. A, B and E. Now you just see the duration 4 plus 3 plus 5. What is the number? 12. 12 weeks. Or days you can say. Now the CD 15, 5 plus 10. CBE, how many? 5, 3, 5. It's going to be 13. CDE, this is 5, 10, 5, which is going to be 20. Now which one is the highest? 20 is the highest. So this is the critical path. CD is the critical path. PERT and CPM. PERT is program evaluation and review technique. CPM is critical path method. They are project scheduling techniques. They are coming under the project management. First thing is project management technique that shows the time taken by each component of a project, each task of a project, and the total time required for its completion. This is PERT. This is PERT. CPM is a step-by-step project management technique for process planning that defines the critical and non-critical tasks with the goal of preventing the time frame problems. In PERT, the PERT breaks down the project into events and activities and lay down their proper sequence. That is the task which we have divided. What is the sequence? They are concurrent, they are parallel, they are in sequence, and relationship and duration in the form of a network. CPM ideally suited to projects consisting of numerous activities that interact in a complex manner. That is why we make a network in CPM. PERT is probabilistic model. The CPM is deterministic model. Because the duration is fixed, we know already in advance. In probabilistic, we'll take the optimistic, the pessimistic, and the most likely. And then, for example, let us take optimistic as 4, pessimistic as 7 days, and most likely is 6. So the final duration will be 4 plus 4 into 6 plus 7 divided by 6. This is how that is why we are calling it as probabilistic model. This is PERT is used in non-repetitive jobs like the planning and scheduling of programs. Normally it is used in R&D projects, research and development, where we don't know in advance. The deterministic model, where repetitive jobs like the residential construction, here we can use. The probability model, results are calculated on the basis of events. In deterministic model, results calculated on the basis of activities. As I said, the PERT is related with activities of uncertain time. We don't know the upfront time. And deterministic related with activities of well-known, properly known time. In project scheduling, there are different tasks. You might recall that we first make the scope, then we ooze out or take out the functions, and then we decide the task that will be accomplished to fulfill the function. So interdependencies, there will be tasks which will be interdependent. So these are defined using a task network. So how to make this task? First of all, we need to do the WBS, work breakdown structure. And what is this WS? This WBS is defined for the product as a whole, for the complete product, or for the important, you can say, individual functions. So for an individual function or a whole product, we divide it like 1, 2, 3 tasks so that they can be dealt easily. Both PERT and CPM, they provide the quantitative tools. PERT is the project evaluation and review technique. CPM is the critical path method. Now in these two are the project management methods, scheduling methods basically. So how do we do this? We determine the critical path, and critical path is what? This is the longest path with critical activities. That is the longest path possible from the start to finish is the critical path. This is the chain of tasks that will determine the whole duration of the complete project. So the longest path is critical path, deciding the actual duration of the project. So both PERT and CPM tries to do that, and they try to determine critical path, especially the CPM does that. And then we use the statistical model. For example, I'll just give you an example. We have already seen that. We try to find out the optimistic value, then the pessimistic value, and then the most likely value. And we use this statistical model. That is, for example, somebody says 4 days it will complete, pessimistic says 7 days, and most likely is 6 days. So we just add them with giving a weight of 4 to the middle one, and then we add and divide it by 6. So we are basically establishing the most likely time estimate for the individual task using a kind of statistical models. Basically, duration is the key. And then we try to calculate the boundary times that will define a time window for a particular task. Time window boundary, it just means when it is going to start in your project and when it is going to end. What is a Gantt chart? So Admiki, he was the first, he was a Russian. He proposed this chart, but he wrote it in Russian, so it could not, propagate that much. Then Henry Gantt, he was the key to propose it, to actually publish it and to represent it. So Gantt chart, if you see now, is just like any table. Okay, this is just like a table. And if you want to get into more detail, then this is the x-axis, this is the y-axis. Now the x-axis, y-axis. Y-axis, we have all the tasks which we have decided. And these tasks are to be done. And when to be done is on the x-axis. On x-axis, we have the time. We have the dates. For example, planning. Planning will start from here. This is the starting date. This is the whole duration in this color. And finally, the end is the end duration. So this is the duration of planning. So from here, you can see the schedule. You can find out when it is going to complete, and we can track and control also. There are certain tasks which are going to go in concurrent. There are certain tasks which are going to go in sequence wise. And then we have different representation like the diamonds, etc. to represent the milestone. So this is basically the representation of task on a time scale. Okay, it will give you an idea as a project manager how the things are going. So a Gantt chart is a project management tool. Software or any kind of project. This Gantt chart is a project management tool which enables you to schedule your work over a period of time. That is, when it will start, what is the duration? That means when it will end. And this can be very useful if you have a big task, big function, say. You can divide it. For example, design activity is a big activity. So we have to define and derive the task from it. So it can be useful for breaking down the big piece of work into a series of tasks. And then we can do the planning, when to complete which task, how to sequence it, which one will come after which one. So Gantt chart shows the activities or the task or the work, whichever you say, of a project mapped against a time scale. Y-axis, task or activity or work. X-axis, it's time. So it's a time scale. You know what is going to happen when. And this is used to plan a project as a project manager, and sequencing the activities. As I said, they can be sequenced, they can be concurrent, they can be overlapping, and setting them out in the order in which they are supposed to be completed. So let us take an example. This is a very simple project management example of Gantt chart. Now on this, the second column you see is basically the task. So the first one is the task name. So the second column, here you see a box I have made. This is the first one is task name. The second block is saying this the main task. it is called as a summary task, and those tasks below it are called the subtask of this summary task. So you can call it as a main task also, having this subtask as book tickets and pay agent. The third one is the start date of that task, when it is going to start. The start date determines the start position of the task bar which we are going to make. The finish, the fourth one, the finish is the date which is determining the end position of the task bar. Then we have the duration. Duration is the start and finish. The duration is the time between start and finish. So the difference between end and start is the duration. For D we have written, D stands for days. You can write 4H for hours. You can write 4W for weeks. 4 weeks. Okay. So this task whose duration will be 0 is called a milestone. You see, this is also a task, but it is a diamond. Here the duration is 0 and this is a milestone. That is, a substantial significant work product will be produced after previous task. The sixth one is the percentage completion, and this is indicating the progress of a particular task. Then you see here that this is 25%. 25% is complete. So you see that whole task bar is divided into two colors. The first color is 25% of the whole bar. 25% is a different color. The whole bar is of a blue color. For example, one day 100%, that is the whole of the bar, will be in the completed color which has been chosen. Okay. So now the next one is the lines which you see. The lines are nothing but the connector lines. The connector lines between the task. And this shows the sequence also. And finally, you see, this is the actual thing which we want to represent. And this is a task bar. This is a task bar. Okay. So now these tasks, if you see here, they are in a parallel, they can be in sequence, they can be concurrent, there will be some work product, and they are all on the timeline scale. So timeline charts or Gantt chart. When we are creating a software project schedule or any project schedule, we always start with a WBS, work breakdown structure. We start with actually getting a task. For example, a school event, there will be some inauguration, some invitation, then who is going to dance, some cultural activity, and finally who the teacher or a principal will address you, and there will be a refreshment, there will be some gifts, etc., some prizes. So this is a whole function or a work. We just want to divide it into tasks, like food is a task. So if automated tools are used, this WBS work breakdowns is the input as a task network or task outline. So this work WBS is the input for this, for the making of task network and the task outline. First you have to make the task that can only be done using the WBS, and for each task, the start date, the duration, and also the effort needed will be there. Effort needed means the person to be employed. So a task, for example, the effort, you have devised the duration and the start date. When you know the start date and duration, you know the end date. And this task may be or it will be assigned to certain individuals. So if you see here, there are certain timeline. These are on the first column of both the pictures you see. These are the task name. These are the work task. So this work task on a time scale is the Gantt chart or a timeline chart. So a timeline chart or a Gantt chart can be developed for the entire project. You can make it for the whole project, or you can also do it if the function is big and having a significant impact. You can also make it for that. So let us see, this is an example of a software project schedule for a concept scoping task of say word processing. Okay. Now here are the tasks. All project tasks are listed here on the left hand column. on the left hand column. These are all the tasks you need to complete. When to complete? This is on the horizontal bars. These horizontal bars are indicating the duration of each task. The first picture is showing the weeks and days. The second one on the right hand side is showing it in terms of the progress bar type. Progress bar. This is the progress bar. Okay. So this is the horizontal bar I am talking about, and this is duration of each task. Multiple bars, if you see at the same time on the calendar, what it is implying? It is implying the task concurrency. They are taking place at the same time. And the diamonds, zero duration time, it indicates milestones. Certain work product is going to come here. Then the project tables can be produced, a tabular listing of all the project tasks, their planned and their actual start and end dates. And this is a table simply, and that is called as a timeline chart developed by Abiliki and then forwarded by Mr. Henry Gantt. So this is a Gantt chart to schedule and to track and control. Now, tracking and controlling the schedule, project schedule is now a roadmap. Now, when it is in front of us, we can track and also we can control task and milestone. If you are here, you know what all are completed, what all is going on right now, and what all have not yet been started. So from here, you can easily track and then you can control. So first of all, how do you actually track? Because you need to be very sure about your milestones. So the ways of tracking is, these are very simple ways. Everyone knows that these are common sense, that you need to meet people, ask them the progress, report, tell them that give us the reports, and ask for the problems. You can evaluate all the results you have got from the reviews, and this has to be done for the whole software engineering process. Basically, you are reviewing with meeting, you have a chart in your hand, you are just asking. And then you need to see whether the diamonds, which are the actually milestones, significant work product, these are accomplished by the scheduled date or not. And then you have to compare this actual start date to the planned start date for each project task in this resource table, or the Gantt chart, you can say. This is not a Gantt chart actually, this is a resource table. The Gantt chart is on the right side. The left hand side is the resource table. Now you can easily find out, okay, this work is not yet been completed. Oh, this work is completed. So you can also go to the practitioners, which are the actual programmers, and you can also obtain from them what is the progress status and what are the problems you are facing. And then you have to mitigate. Then you will use the actually mathematical concepts like the earned value analysis in order to assess progress quantitatively. Let me tell you, earned value analysis will tell you about the time where you are cross the time, or you are before or ahead of the time, and the cost, whether you are under budgeted or over budgeted. The time and cost will come from earned value analysis. How do we control? The tracking and controlling you are doing through this Gantt chart and the resource table, left resource table, right Gantt chart. Now, when you, as a project manager, you would like to control the project, what do you do? First of all, the control is basically a car you are going. So if you want to control yourself, you will leave the accelerator. If you want to go somewhere urgently, you will put pressure on the acceleration. So as a project manager, you will administer, try to find out, oversee, foresee project resources, and then you have to cope up with the problems, because as a project manager is all about mitigating the problems, reconciling the problems, solving the problems. And then you have to direct your project staff. This has to be done, this has not to be done, and what has to be done when. This is how we control. This is how we take control of anything which is going on as a project manager in your project. So as a project manager, if things are going well, say you are getting all the milestones done, like the project is on schedule, you are within your budget, you are reviewing every time, and you are getting a good progress, the milestone are also being achieved on time. So when you get all the schedule, budget, progress, milestone, all these are there and they're going well, then the accelerator will not be pressed that hard. The control will be light. Okay. But when there is a problem, then as a project manager, you need to exercise the control, because now you need to reconcile, you need to see situation and then act accordingly, act as quickly as possible. For that, what you will do, you may put additional resources, or this is the problem area, this is the task which is hampering the situation, so we will add resources. It can be hardware, it can be software, it can be people even. So as I said, people can be redeployed. That is, one person from another part can be redeployed here. 2 people are needed, 3 can be deployed, or either you can do the hiring also. And the project schedule can also be redefined. Redefined is important because here you are changing the schedule of all the other activities. Now here is a concept called time boxing. Market driven projects are bound to give you the deadline. So when you are faced with a severe deadline pressure as a project manager, and if you are experienced, what you will do, you will use a project scheduling and control technique, and that is called a time boxing. This is just a way to mitigate and try to see situation where you can actually get the product delivered on time. It is nothing else. It's just time boxing. You know the task, put it in time box and complete it. When to complete it, when to start another project, another task. So that is the thing an experienced project manager will do. So complete product, it is possible that it may not be deliverable or delivered by a predefined deadline. In a project schedule, there is a deadline. You are not able to do it as a project manager. So for what you will do, the best way is to adopt the incremental software paradigm. In software development lifecycle, we have talked about waterfall, spiral, and the agiles, etc. Here you will use, even if you want to use the agile, you will use the incremental software paradigm. And the schedule is derived for each incremental delivery. I am saying every delivery, a schedule will be made for every delivery, not for the whole completion of the functionality of projects. And the task associated with each increment will then be time boxed. That is, first increment you are giving, second increment you are giving. I am saying for a single increment, you will make a schedule, try to find out the task, and then all these tasks will be kept in a time box. Time box is nothing but the start date and finish date. Nothing else. Time box is just a start date and the end date. So now you have a single increment. You have made a single schedule for it and devise the task and put it in a time box. This means what are you doing is the task associated with each increment, we have time box, so that schedule for each task is adjusted by working backward from the delivery date for the increment. That delivery date for that increment, you're going back and then you will readjust the task timing according to that. Because this is an incremental type of software paradigm. A box is put around each task. And now when this task is going on, when a task is progressing, the task is going on. When the task is 90% complete, for example, a task hits the boundary of the time box, it can be plus or minus 10%. It is always minus 10%. So when the 90% is done, you will start the new job. You will now the work for the first task will complete and the new task will begin. So question will be from your side, if the work is not yet finished, how can we proceed? What about the 10%? This is the key here, time boxing. By the time the time box is encountered, 90% of the task has been complete. So the remaining 10% task can be delayed to the next increment or it can be completed later. The main key is rather than the 10% task has not been done, so it will not be done. So rather than stucking on a task and hampering the project schedule, the project proceeds towards the delivery date, starting the new task. That 10% can be done in the next increment, can be completed later, but these 10% will reduce your delivery time and the severe deadline pressure can be achieved. This is the whole idea of time boxing. Okay, time boxing is nothing but putting task under a boundary. Tracking progress for an object-oriented project. Now, in object-oriented project, the best way or the best framework is to use an iterative model, and the different milestone can be achieved, and that can be considered to be complete. That okay, this milestone, this milestone, this milestone, that is the tracking progress. So the technical milestone can be object-oriented analysis completed. That is the analysis part. So here the classes which we are going to employ and all the class hierarchy, we would have been defining it and reviewing it. The class attributes, each class attributes and operation have been defined and they are being reviewed. Then the class relationship, what relationship do the class have, hierarchy, etc. They have been established and reviewed also. And the behavioral model that has been created and reviewed, and the classes which we are reusing have also been noted down. So this marks the completion of the first milestone. So we can say that this first milestone is achieved, is completed. The second milestone will be the technical milestone of object-oriented design. So here the whole software will be divided, or the system will be divided into subsystem, and these subsystems, they are being divided and they are being reviewed. Then the classes are allocated to these subsystem which we have just defined and also being reviewed. Along with this, the task allocation, because the activity have to be decided and divided into the task, they are being done, and the responsibilities and collaborations have been identified. Also the attributes and operations, they are also being designed and reviewed, and the communication model between different parts, or you can say subsystems, this is also being created and being reviewed. Then comes the object-oriented programming milestone. So 2 milestones we have already completed. Now this means each new class we have actually coded it, implemented it, and the reuse library like the extracted class, this also have been implemented. The prototype or the increment is properly being built. Once this is done, the third milestone is completed. Then coming to the object-oriented testing. So the correctness and completeness of this object-oriented analysis and design models, this has been done. The CRC, that is the class responsibility collaboration network, this is developed and reviewed. The test cases are designed and the class level tests have been conducted for each class. Then the test cases are designed and the cluster testing is also completed and the classes are being integrated. And then the system level, final level of tests have been completed. This marks the end of the 4th milestone. This is how we track the progress of an object-oriented project. Scheduling for web application and mobile projects. So when we do the web and mobile app, we are talking it together. So this scheduling means distributing of estimated effort across the planned timeline, that is the duration, for building an increment. So these web app and mobile projects, they are built in increments, and the overall schedule is not made once. It evolves over time. For example, the first iteration, there will be a macroscopic schedule, that is the big schedule, not going into the detail. So this will be developed, and this type of schedule will identify what? The web or mobile app increments and the projects, the dates on which each will be deployed. So the entry for this increment on the macroscopic schedule is then refined into a very detailed schedule to make the microscopic schedule. Here we make the task these are identified and they are scheduled. For example, taking an example of a security system, let us call it as safehomeassure.com. So we will do the macroscopic scheduling first for an increment. Let us say it's an nth increment. So we can identify, first we have to identify what are the increments we are going to provide here. So 7 increments, let us say that we have identified 7 increments. For example, basic company and product information, detailed product information and downloads, that is you are going to buy from the company. So the company is doing that. Product codes and the processing product orders, then the actual design part, space layout and the security system design part. So these are 4 increments and we are talking about 7. So 5th will be information and ordering of monitoring devices and the services. And then we need to see also the buying part. So online control of monitoring equipment and then the accessing of account information. So don't go into the detail. I'm just saying that let us say these 7 increments have been finalized. This is the macroscopic schedule we have developed in order to track and schedule and control. So how to do this? See, these are 7 increments. First, we have to consult with the stakeholders and we have to develop a preliminary deployment schedule for all these 7 increments. That is why I'm calling it is a macroscopic schedule. So we will make a timeline chart. You know that is also called as a Gantt chart. So the deployment dates, you see here the diamonds. These are preliminary, very preliminary and may change as more detailed scheduling will do of the increment. Because these are 7 increments we have finalized. But the macroscopic schedule, it indicates management when content and functionality will be available and when will be the entire project complete. So as a preliminary estimate, the team will work to deploy, you see here on the 12th week timeline. And you also see here the 3rd and 4th and 7th. This is the 3rd one, 4th one and 7th one. These are some increments and these will be developed in parallel. That is same time. So now the team is ready to schedule work tasks. For every increment, we have to find out the task. How many tasks are required to actually work or complete this increment? So each framework action and the task can be adapted in different ways. One of the 4 ways actually. What you can do? You have chosen a task and this is applied. You have finalized it and applied. You can see the task and you say, no, this is not required for this increment and you just eliminate it. There may be some new task you want to add. So a new or a custom task is added. Or the task is refined into number of subtasks. That is, you see the task is very big and we can divide it into subtasks. So this becomes a part of a schedule. So these are the ways you can choose the task and discuss about the tasks. So don't go into the detail. I'm just saying that let us say that the 4th one, which is the design, the interface part of this safehomeassure.com we have taken. Now just consider this. And this was a macroscopic event or activity. Now, we would like to make the task for it. Okay. So the 4th increments start at 5th week and terminates at 9th week. So what can be the subtasks? So just don't worry about all these. I'm just saying that there are certain things which we have to do. Like making a page layout. Then, you have to review it. The space layout mechanism, drawing board layout, and then the procedural details for the graphical wall layout, wall length computation, display function, procedure detail for graphic window layout and graphic door layout, and then the selection of the system components like the sensor, cameras and microphones, and then the procedural details for the graphic layout for security system components, and then we have to conduct the pair walkthroughs as required. So these tasks, which are the actually main application part of that increment, will become the part of the increment schedule and they are allocated over the increment development schedule. So they can be input to any software, scheduling software like the Microsoft project, and then you can track and control. Earned value analysis. Now this EVA is a technique for performing quantitative analysis of progress. That is, the progress of your project can be estimated, can be numbered. Humphrey says, this EVA provides a common value scale for every task. It can be any kind of task. The total hours to do the whole project is first estimated, and every task is given an earned value based on its estimated percentage of the total. That is, you will get the duration and you will get the cost at particular point, particular juncture of your schedule. So earned value is a measure of progress. It is also a measure of percent of completeness. As I said, it gives us the quantitative analysis. Fleming and Koppelman, he argued about EVA that if your project has a schedule, say 100% is your schedule, when you reach 15%, just by then it starts giving you very accurate and reliable readings, the numbers of performance in terms of duration, cost, whether you are ahead, whether you are behind. So there are certain terms you need to understand. First thing is, this is the planned work. This is what we have planned. Okay, this is going to happen. Now, at particular time, say at this time, you want to assess where is your project. So the actual AC is where the actual cost is there, and the EV is showing actual work accomplished. Cost is money, work is person month. How much work is accomplished is EV. What the work actually is costing is AC, and PV is the actually planned cost, planned schedule, right? So this x-axis difference will give you the lag or the extension, and this time difference, okay, this gives you whether you are ahead of your project or whether you are at this point, whether you are behind the schedule. Okay, this graph is showing, or this earned value analysis is all about telling you duration or time and the schedule cost, that where you are. Okay, for that what you are going to do, see, we'll try to find out the index also, like the cost performance index and schedule performance index. So if these indexes are less than 1, that means you are either over budget or behind schedule. And if it is greater than 1, you are under budget or you are ahead of schedule. We'll take an example on this, and then you will understand all these terms and the way how it is done. There are certain steps to determine the earned value. First one, EV, we'll call it as BCWP. This is the budgeted cost of work performed. AC will be ACWP, actual cost of work performed. PV will be BCWS, budgeted cost of work scheduled. So BCWS is what? Budgeted cost of work scheduled. This is determined for each work task represented in schedule. So if you have task 1, task 2, like this task N, the different tasks in the schedule, okay, with different timelines, that where what will happen to when. So now this budgeted cost of work schedule is, you are talking about work in person hours or person days for each software engineering task, that is task 1, task 2 till task N. So you will try to find out all these costs, and then that is the effort, sorry, the effort. Now this BCWS is the effort, person month, person days. Now for each task I, you have to find out BCWSI. Okay, so now you are going to combine all of this. So BCWS will give you budget at completion, BSE, which is simply the addition of this BCWS. BCWS is budgeted cost of work schedule. That is what you have anticipated, what you have planned. Okay. Now next we'll compute the BCWP, budgeted cost of work performed. Work scheduled is done. Now you are going to find out work performed cost, not scheduled cost, performed cost. So PV is planning, the work with the schedule, and budget is the plan. AC is the actual result, which we are going to do later. But here we are trying to find out BCWP, that is the EV, which is the earned value this is looking at the budget amount for the work performed. So the value of BCWP is computed just like BCWS, and BCWP is the sum of these BCWS values for all work tasks that have actually been completed by a point in time. You want to find out at certain time, these are actually being completed. So let me tell you about BCWS and BCWP. BCWS, this represents the budget of the activity that were actually planned to be completed. We have planned it. But BCWP, this represents the budget of the activities that are actually completed at that particular point. Okay, what is budgeted? What is completed? Now this we have BCWS, BSE and BCWP. You can find out the SPI, that is the BCWP by BCWS, and the schedule variance also, BCWP minus BCWS. So these will give you certain indication, like the schedule performance index. If it is close to 1, everything is going fine. It indicates efficient execution of the project schedule. This SV, which is the schedule variance, is the absolute indication of variance from the planned schedule, whether you are ahead or whether you are behind. You can also find out the percent scheduled for completion using BCWS divided by BAC. Okay, this percent scheduled for completion you will get here. Now, as I said, the BCA, which is providing an indication of the percentage of work. Okay, now this BCWS we have already done, this sigma. I am saying that this is PV, and PV is nothing but budgeted cost of work schedule, and percent this complete is BCWP by BAC. Okay, now let us come to the actual cost of work performed, ACWP. So this is the sum of effort actually expended or invested on work tasks that have been completed by a point in time on the project schedule. This is the actual cost till that point. You have planned $180 dollars. This is the actual cost. So the cost performance index CPI can be computed by BCWP by ACWP, and cost variance can be computed by BCWP minus ACWP. And if this, again same thing, I will take an example. Okay, a CPI value close to this one, it shows the project is perfectly fine with respect to budget amount. Previously it was schedule, now it is talking about budget. So like the radar, it knows what is coming. So this EVA eliminates the scheduling difficulties before they are apparent. So this will enable us to take the corrective action before any kind of crisis comes or criticality develops. This is the earned value analysis. Let us take an example of earned value analysis. This is a project schedule. So we have 5 tasks: gather requirements, create design, build machine, test and refine, and roll out. And these needs to be completed in 14 days. And every task is given a time. Now we would like to find out what is the status of our schedule of our cost at the end of 8th day. How do we find it? So we have certain input values or input tables or inputs domain values. So we need to find out from here. It is already given activity or task. This is going for 3 days. Gathering requirement 3 days. And the cost for 1 day is 800. And the total cost is 2400. 8 3s are 24, so 2400. Likewise, all will come. Time is also given for each task, each activity. Cost per day is also given, and the total cost. Now you see this 700 for 4 days, 2800 total cost. But we'll just talk how much it is being completed. That is all earned value analysis we are going to do. Now there is one more table, and this is also input. Okay, at that time, after 8th day or at the end of 8th day, the total incurred cost is also given in the table, and this is also known what is the actual percentage completion. So build machine, if you see here, this is taking 4 days. But just 3 days happened. So only 3/4 work is completed, or 3/4 schedule is completed. Similarly, test and refine 1/4 we are taking only, because we are just trying to find out at the end of 8 days. So actual percent completion is also given. The gather requirement, create design is completed. This build machine, it is already given 50% complete, and test and refine 25% complete. Rollout will not consider because it is not all even started. Now this will be the table we are going to make for the earned value analysis. First thing, AC. That is how much this AC, or this first thing is the total of cost supported in achieving work on the activity during a specified period. So this is the actual cost. Actual cost is what? You have to take, this is the total cost. So this is the incurred cost. So what is the actual cost? It is the incurred cost. So we are going to take the incurred cost. So this column we will take directly 2400, which this one, okay? So this is 2400, 1500, and 2700, and then 700. I'm just taking the incurred cost, which will be our actual cost, right? See, rollout is not even in picture, so we'll give a 0 here. Now coming to EV. What is the EV? This is the value of work completed at a given time. This is actually the earned value. So what is the EV here? See, what actual work is being done before this time, end of the 8 day, EV. So how do we find it? See, the last column of the second table and the last column of the third table, that is the total cost, is this one, and actual percent complete is this one. So you will take the cost, multiply it with the percent, and you will write the value. 2400, 100% is complete. So what will be the value? 2400. So just write 2400 here. 1200, how much complete? 100%. So 1200. 3600, 50% complete. So 50% is half. That is going to be 1800. So now you can write 1800 here. Coming to the test and refine, which is 2800. 25% is complete. This is given in the table. So you can also find using the unit cost per day, but just take 2800 and 25%. That is going to be 700. And 0 for the rollout. Now what is the PV? This is the part of the approved cost estimate planned to be spent on the activity during a specified period. Okay. So what was planned? See, let us, though the first and second will not have any problem because they are already completed. So gather problem and create design. So just write the value 2400, and this is the cost, which is your 1200. Now come here. This is the 3600 cost. What you are going to write here? See, if you see, there are 3 days, 6th, 7th, and 8 days. 3/4 part is what it should do, or it should have done, whatever. Now, so you have to take the 3/4 of 3600, or 1 day cost is 900, and there are 3 days, 6, 7, 8 days. So 900 into 3 means multiply the 900 with 3. 9 3s are 27. So you can write 2700 here. Okay. Now same way you are going to do for the test and refine. Test only 1 day, 8th day. Okay. So 1/4. 1/4. Or you can do one more thing. You can just 1 day. So 700 is the cost per day, and effort 1 day is 700. So just write 700 here. Okay. Now what you have to do? Just add all of these in column. So when you add this first column for AC, you will get 7300. Now coming to EV, when you add them, you are going to get 6100. PV, add them, you are going to get 7000. Now coming to CPI. CPI is computed using a relation which is EV by AC. Now you can do for each of the activity. That is also possible. But for example, to make the computation easy, I am just going to do the final one. That is the total. So CPI is EV by AC. EV total is 6100. AC total is 7300. So CPI will be 6100 divided by 7300, which is going to be 0.84. Okay. Similar way, CV will be found out. CV is what? It's EV minus AC. What is EV? Total is 6100. What is AC? 7300. So you can do for one by one also, row wise, but we are doing for the final. 6100 minus 7300, and that is going to be minus 1200. But you see it is a negative value. That means there is a problem. Negative means problem. SPI, these are going to give you index. CPI, SPI and index. So SPI is given by EV by PV. What is EV? EV total is 6100. What is PV? PV total is 7000. What do you get here? If you compute it, you are going to get 0.87. Just write it here, 0.87. Now coming to SV. SV is EV minus PV. I am just doing it for the total. So EV minus PV is going to give you, EV is 6100 and PV is 7000. So you are going to get negative 900. Again a negative value. That is again a problem. Okay. Now let us analyze the result. We have computed. You know how to compute now. See, this is 0.84. This is less than 1. That means, since it is less than 1, it means that you are over budgeted. At this point, at the end of 8 day, the project is over budgeted. If it would have been greater than 1, it is below budget. Now cost variance, negative 1200. That means, negative means you are over budget. So CPI, CV are showing the budget part. SPI now 0.87. That is, it is again less than 1. And we are less than 1. That means you are behind schedule. You are behind schedule. And SV again negative 900. So this is also talking about the negative values showing that there is a delay. There is a delay. So this is how we analyze the results. Okay, this is all about this topic. Thank you so much. Take care of yourself.